Hi everyone, welcome back to my channel. In this video, we'll solve the following differential equation y prime plus y is equal to y cube. Note that this is a Bernoulli's differential equation because Bernoulli's differential equation has the general form y prime plus px times y is equal to qx times y power n. So note that here we have this extra term y power n. So here this term is y cube. So to solve this kind of Bernoulli's equation, we need to divide this equation by y to the power cube. So by dividing y to the power cube, we get y to the power minus 3 y prime plus y to the power minus 2 is equal to 1. Now we'll make a substitution, which is y to the power minus 2 is equal to u. Then by derivating both sides, we get minus 2 y to the power minus 3 y prime is equal to u prime. So y to the power minus 3 y prime is equal to minus half times u prime. So by substituting, we get minus half u prime plus u is equal to 1. So by simplifying, we get u prime minus 2u is equal to minus 2. So note that we get a first order linear ODE, and we know how to solve first order linear differential equation by finding integrating factor. So integrating factor here will be e to the power integral coefficient of u, which is nothing but here minus 2 gx. So it will be e to the power minus 2x. Now multiplying by integrating factor in the both side of this equation number 1, we get ddx of u e to the power minus 2x is equal to minus 2 e to the power minus 2x. So u e to the power minus 2x will be integral minus 2 e power minus 2x dx, which will be minus 2 e power minus 2x by minus 2 plus c, which is nothing but e power minus 2x plus c. So we get u is equal to e power 2x times e power minus 2x plus c, which is 1 plus c e to the power 2x. And what is u? U is nothing but y to the power minus 2. So general solution is y to the power minus 2 is equal to 1 plus c e to the power 2x.